Take some molten sodium chloride in a crucible. Introduce 2 metal rods and connect the circuit as shown. We observe that the bulb glows, indicating the flow of current. Now repeat the activity using solid sodium chloride. The bulb in the circuit does not glow. Pour some water in a crucible. Notice that the bulb glows. This activity shows that the current does not flow through the solid sodium chloride, but it flows through the molten and aqueous solution of sodium chloride. Why does this happen? A compound such as sodium chloride, which allows the passage of electric current either in a fused state or in an aqueous solution, is called an electrolyte. Sodium chloride is an ionic compound in which sodium and chloride ions are held together by an electrostatic force of attraction. These ions are not free to move. Due to the absence of free ions, solid sodium chloride does not conduct electricity. When the same sodium chloride is heated, a bond between sodium and chloride ions weakens and breaks. The ions become mobile and are able to conduct electricity. Dissolving sodium chloride in water also produces free ions. Hence, an aqueous solution of sodium chloride also conducts electricity. Thus, motion of free ions is responsible for conduction of current in an electrolyte. Examples of some other strong electrolytes are copper sulfate, which dissociates into copper ions and sulfate ions, hydrogen chloride, which splits into hydrogen and chloride ions, and so on. We will now study the mechanism of electrolysis of molten sodium chloride in detail. In a molten state, sodium chloride exists as sodium ions and chloride ions. These ions are in continuous motion. Dip 2 metal electrodes in molten sodium chloride, which are connected to positive and negative terminals of a battery. The electrode connected to the positive terminal is called anode, while the one connected to negative terminal is called cathode. When the battery is switched on, electrons move from the negative terminal of the battery through the metal wire to the cathode. This results in an excess of electrons on the cathode and generates negative charge on it, whereas the anode develops a positive charge. Sodium ions, being positively charged, are attracted toward the cathode. These ions accept the electrons from the cathode and get reduced to sodium atoms. Chloride ions, being negatively charged, are attracted towards the anode. Here, these ions lose the electrons and are oxidized to neutral chlorine atoms. Two such chlorine atoms combine to form a molecule of chlorine. Reduction and oxidation take place simultaneously at cathode and anode respectively during electrolysis. The complete assembly containing electrodes, electrolytic solution, and a battery is called an electrolytic cell.